Construct a 99% confidence interval on the population proportion using the given information. We have x equals 125, n equals 250, and we're asked to find the lower bound and the upper bound. So first, as we see here, let me just do this without technology, just to sort of show you how this has connected to our lesson on sampling distributions. So we go ahead and write down x and n. So x is 125, n is 250. So what is my point estimate? What is my sample proportion? Well, it's 125 over 250, x over n, which is 0.5 or 50%. So now what I need to find, so if all I had were one number to estimate whatever this context is, what kind of context phrase, I just wanted to focus on how to generate this interval. If I only had one number, that would be it, 50%. But I know there's a little bit of an error here, right? Because different samples are going to produce different p-hats. And let me briefly show you what I mean. I've pulled up the sampling distribution applet in StatCrunch, and I have my proportion is 0.5, sample size of 250. And if I were to take a sample, let's just do it one time. This particular sample got a p-hat of 0.42. I can do it again. And this particular one looks like around 0.5 or so. And we see the average here is 0.458. I can do this a bunch of times. Here's 5 times. But we see where it's sort of all huddling around this one value of 0.5. The question is, we don't know which one of these samples we actually got. So we're kind of we're gonna sort of reverse engineer this and go back. Let me show you what I mean. So again, I need to know sort of how my p-hat is 0.5, and I need to kind of build a margin of error around there. And I can use my standard error to help me do that. So the standard error, remember, the standard deviation, remember, of this is the square root of p times q over n. The problem is we don't know p or q. So we have to use p-hat and q-hat, and we call that the standard error. And so we use SE sub p-hat, and it's just p-hat, q-hat over n, and take the square root of that. So in our case, it's 0.5 times 0.5 divided by 250. Take the square root, you get 0.0316. Now what we do is we use our z value. How many standard deviations do I actually want to go out? How many standard errors do I want to go out? Well, with 99% confidence, I have to go out 2.576. And if you ever forget what the one is, you can go to the calculator and press second distribution and go to inverse norm number 3. And ours is a 99%, but remember we have 2 tails, and so we always just divide that by 2, leave the mean at 0, standard deviation at 1, and let's just do the left. And press enter, and there we go, 2.576, and we just sort of discard the negative. So that is our critical value. So remember, to build the interval, we just take our point estimate times that margin of error, and the margin of error is z star times SE sub p-hat. It's a lot of notation. We're not going to really be building these by hand, but it's good to sort of see where these numbers come from. So in our case, it's going to be 0.5, which is p-hat, plus or minus 2.576 times our standard error, which is 0.0316. Just so we can see what that margin of error is, I went ahead and crunched that out. It's going to be 0.5 plus or minus 0.0814. So we're going to add 0.0814 to 0.5 and then subtract 0.0814, and we get our interval 0.419 to 0.581. So that was a mouthful. Let me show you how to do this on the TI and on StatCrunch. Okay, so on the TI, I'm going to go ahead and press Stat, scroll over to Test, and go down till you see 1 prop z interval. There it is right there. A, 1 prop z interval. We have 125, 250, confidence level. You can either put 0.99 or 99. It knows what you mean. And then press enter. And there's our interval. Notice it gives me p-hat at 0.5. And we get almost the same thing. I think I did some rounding. So we have 0.4185 and 0.5815. Let me show you how to do this on StatCrunch. So let me show you a familiar way that we've been using is the normal calculator. We can go to calculator, come down here to normal, and we can just put our stuff in. We've already computed the mean, 0.5. Standard deviation, 0.0316. We want this between, so let me click the between button, And we want the between here to have an area of 0.99, right? That's the 99%. Press compute. And there are the values right there. That's kind of nice, isn't it? But I can do something even better. I can run the test itself. So I can go to stat, proportion stat, one sample with summary. And let me let you think about that for a second. So we're talking about proportions. In this class, we're pretty much going to talk about proportions or means. If we do proportions, we go to proportion stats. If we do means, we're almost always going to go over here to t-stat. So these are the two you're going to be using. So summary data, number of successes, we said was 125. That's our X. Number of observations was 250. And you're going to choose confidence interval and change that to 0.99. The method should default to the standard walled method. And press compute. And we had exactly the same thing we obtained in the normal applet and on the calculator and by hand. So I hope that helps. And you want to go ahead and put in the lower bound, lower limit, and the upper bound, 0.419 and 0.581. It should cut you a little bit of slack with rounding, so if you put 0.418, it should give you credit, but let me know if it doesn't.